this question. Question says that a NPN transistor operates as a common emitter amplifier with a power gain of 60 decibel. So power gain is given in a decibel, that is power gain in decibel, it is given 60 decibel. Okay, and the further question, the input circuit resistance is 100 ohm. So R input is given, R input 100 ohm, and the output load resistance is 10 kilo ohm. R output is given, which is 10 kilo ohm. Now the question has asked the current gain, the common emitter current gain beta. So we need to find out the beta, that is current gain. So we need to find out current gain. First of all, we have given with the power gain, but it is in a decibel, 60 decibel. So we will calculate the power gain using the formula, that is power gain in decibel is equal to 10 into log base 10 AP. Here AP is a power gain. So we will calculate the power gain, and the power gain in decibel is given. So power gain in decibel is 60 is equal to 10 into log of base 10 into AP, that is power gain. So from here, taking the base 10 both sides, so 10 to the power 6 is equal to AP. So power gain is equal to 10 to the power 6. So this is the power gain we have calculated. Now we know that the power gain is given by formula AP is equal to voltage gain into current gain. So AV is a voltage gain and beta we need to find out, and AV is also given as the formula for the AV is voltage gain is also given at beta into R output by R input, resistance in output by resistance in input. So we will replace this second equation into the first. So power gain AP is equal to beta into R output upon R input into beta. So this will become power gain AP is equal to beta square into R output upon R input. So here from here we will calculate the beta. So beta square is equal to, so beta square AP into R input upon R output, and we have all the values of R input, R output and the power gain. So we will just put here. So beta square equal to R input, it is 10 to power 6, power gain is 10 to power 6 into R input 10 100 ohm, and R output is given, that is 10 to power 4. Therefore from here beta is equal to root 100 10 power 6 into 100 upon 10 to power 4. From here it is 10 to power 4 upon 102. Therefore beta comes to be 10 power square. So the power gain, so the current gain is 10 to power 2. Now let's see which option it matches. So option A 10 to power 2, that is 100. So hope you guys understand. Thank you.
Hello everyone, the question says that an NPN transistor is used in common emitter configuration as an amplifier with 1 kilo ohm load resistance. Signal voltage of 10 millivolt is applied across the base emitter. This produces 3 milliampere changes in collector current and 15 microampere changes in base current. of the amplifier, the input resistance and voltage gain are. So in this question I have to find out input voltage and voltage gain. First we will write its input current. So because we have given an NPN transistor for common emitter, for common emitter configuration, input is base. So first we will write input current. So input current is 15 micron, that is 15 into 10 raised to power minus 6 ampere, and collector current is, so collector current is 3 milliampere, so it is output current. So output current is 3 milli, 3 into 10 raised to power minus 3 ampere. We have also given output resistance, that is RO. Output resistance is 1000. We know V input will be equal to so signal voltage is 10 millivolt, that is equals to 10 into 10 raised to power minus 3. So we can also write V input equals to R input into I input, input resistance into input current. So V input is 10 into 10 raised to power minus 3, R input is as it is, and I input is 15 into 10 raised to power minus 16. So on solving, R input will become equals to, so R input will be equals to 10 into on solving this value, it will become 10 into 10 raised to power minus 3 divided upon 15 into 10 raised to power minus 6. Now on solving this equation, so after solving this equation, we get input resistance as 0.67 kilo ohm. So for voltage gain, we know voltage gain. So formula to find out voltage gain is V output divided upon V input. So V output is given, that is equals to 1000 into 3 into, so we can write this equation as 1000 into 3 into 10 raised to power minus 3 divided upon V input is 10 into 10 raised to power minus 3. On solving this value, we get its value as 300. So it is our answer. So hence our final answer is input resistance is 0.67 and voltage gain is 300, that is option B.
Hello everyone, in this question we are given that a common emitted amplifier circuit built using a NPN transistor is shown in figure. Its DC current gain is 250, RC is 1 kilowatt and RC is 1 kilo ohm and VCC is 10 volt. Then we have to find what is the minimum base current for BCE to reach saturation. So first we apply KCL in this circuit and find IC. So when applying KVL, then VCC minus ICRC equals to 0. Then VCC equals to ICRC. Then we have values for BCC and IRC. Then VCC is 10, IC into 10 to the power 3. Then IC is equals to 10 milliampere. So we have found IC as 10 milliampere. So then what is asked us in the question, that is IB. Then we have a relation between IV and IC. IC is equals to beta IB and beta is given to us 250. Then IC 10 into 10 to the power minus 3 is equals to 250 into IB. Then IB is equals to 10 by 250 into 10 to the power minus 3. Then IB is equals to 4 into 10 to the power minus 5 ampere, or IB is equals to 40 microampere. So this is our answer for base current, 40 microampere. It is given in the options, this one options. Thank you.